Greetings. So this video we come to sort of the key point, the key term that we're going to be working on for the next few videos, and that's called a conservative vector field. So we've already covered the formal definition in class. This video is going to kind of focus on what's a quick and easy way to remember what that means. So our informal definition says if you have some function f of x, y, we would make a vector field that's called conservative if we find the gradient of that function. So then the gradient of f of x, y, which is the same as the vector you get when you do the x partial derivative and the y partial derivative, because there's two components, f with respect to x of xy and f with respect to y of xy. This vector we just made is a vector field, and that vector field is called conservative. So the quick and easy definition for conservative vector field is it is the gradient of a function. And so to add a little bit more detail to this function little f of xy that we started with is called the potential function of or for the vector field. So these words here that we're working with, let me just make the screen a little bit different here. Potential function and conservative vector field here. Don't think of conservative like a political statement. Think of it in terms of, in physics, conservation of energy. If the vector field is conservative, there's going to be some special physics properties that come around, some of which we'll study in this chapter. And the function that kind of gave birth to the vector field by taking the gradient, that function is called the potential function. So think potential energy versus kinetic energy. So if your vector field comes from the gradient of a function that's called a potential function, then we have a vector field that's called conservative. That also sort of hints at the fact that it's possible that there are vector fields that don't come from gradients, and we'll be studying those in future videos. There we go.